All right, welcome to Unit 5, Section 2.1, Precision. What are the measurements shown by each letter? So when you're looking at a ruler that's dealing with inches, inches are divided into sixteenths. So if you can see this, 0 to 1 inch, there's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different little tickies in there. So inches are divided into 16th. A would be 1/16, meaning you write it as 1/16 of an inch. That's what the two tickies mean. When you look at B, B is 2/16, or we can simplify it to 1/8. C, 1, 2, 3, 4/16, but we know 4 fits into 16 4 times, so we simplify that to 1/4. D is 8/16, while 8 is half of 16, so 1/2, because it's halfway. E is 10/16, which is the same as 5/8 of an inch. And F, we're 3/4 of the way, or what is that? 8, 10, 12/16, which is the same as 3/4. So that's how you read inches, and when you see inches like that, you'll know now. 1/4 of an inch, you can just figure out is, and they do level them out, so half is the longest, and then the quarters are second. So then the eighths, they do scale them to see them better on rulers. Okay, so measurements are never exact values. There's always some uncertainty due to estimation, error, or both. Well, what is uncertainty? That's the amount that a measurement you record could vary from the true measurement of an object. So a measurement is only as certain as the precision of the measuring tool. Exact values include defined quantities and counted values. For example, there are 12 inches in 1 foot. I have 4 coins in my pocket. What's precision mean? Well, precision is the smallest scale division on the measuring tool. A finer scale makes it possible to measure with less uncertainty. So if you have something that's super, super good, tiny little tickies to get the exact measurement, let's say, of this pencil, you can tell me that this pencil is maybe 12.3342 centimeters. That's more precise than just saying 12. Measurements are uncertain. For example, a roll of wire is 162 feet long. Is each quantity below an exact value or a measurement? So we have 4 options down here. Paul's height is 175. Well, that's a measurement. The gasket has 8 bolt holes along its edge. Well, that's an exact value because there's not 6, there's not 7, there's 8. So that's exact. With Paul's height, he could be a decimal or something less or more than 175. Maybe he's 175.2. But we measured as close as we could. But with 8 holes, there's not a half hole or anything. That would just be another hole. So this is exact. The diameter of a bolt is 3/8 of an inch. That's a measure, because you can measure the diameter and there might be some error in that. And there are 1,000 grams in a kilogram. Well, that's exact, because there's always going to be 1,000 in a kilogram. That's just a value. Example 1, Noel and Carmen have jobs that require them to measure temperature. Which temperature measurement is more precise? So we have one that goes to here and one goes to here. And we have a hint. When a measurement is between scale markings, you can estimate the last digit, but you cannot be certain about it. Well, let's see what we have to write down. Noel's a refrigeration technician. His thermometer is alcoholic and shows the temperature to be inside a meat cooler was about 4. Carmen is a vet assistant. His thermometer shows the temperature of a puppy that's 39.7. So that's what those two values were. 4 and 39.7. Whose thermometer has a finer scale? Carmen's thermometer measures to the nearest half of a degree. Noel's thermometer measures to the nearest degree. So which one has finer? Well, the half degree is better than a degree, so Carmen's thermometer measures to a half degree, so it has a finer scale. It's more fine, it's more smaller. Why do other jobs require more precise measurements than some? Well, some jobs you have to be pretty precise on what you're measuring so that it can fit perfectly in something or get a great reading so you know what's going on more than other jobs. Does, when you're fitting, let's say, a cupboard into a corner for a carpenter, does he have to know that the cupboard is going to be 0.0001 centimeters off? No. He has to get to the nearest centimeter, maybe half centimeter, but he doesn't have to know like the tiniest little sliver of wood off compared to other jobs that you might have to know that. Okay, what temperature measurement is more precise? The precision of a measurement is shown by the place value of the last digit. Carmen's temperature thermometer measurement is more precise because it has a finer scale. Okay, let's look at example 2. Kurt and Janice use different measuring tools for their jobs. Whose measuring tool is more precise? Kurt is a carpenter in Thompson. He frames new houses. He uses the tape measure below. So it looks like we have centimeters and they're spaced out. Or are these inches? Let's see. No, I think, yeah, those are inches. Janice is a surveyor. She uses a leveling rod to the right. 5 and 2 feet. Okay, so let's break this down. What is the smallest fraction of a foot that each measuring tool can measure with certainty? Well, his tape measure is, remember 1 inch has 16 tickies, so 1 in 16 of 1 in 12 equals, well, 1 times 1 is 1, 16 times 12 is 192. So he has 192 of a foot. What they did was take how much tickies the inches had times how many inches in a foot, 12, to get that value. Janice's leveling rod is 1/5 of a tenth of a foot. So 1 times 1 is 1, 5 times 10 is 50. Whose measuring tool is more precise? Explain. Well, we know Kurt's. Kurt's can go to a smaller number. Kurt's measuring tool is more precise. The tape measure has a finer scale than the leveling rod because 1 over 192 is less than 1 over 50. Good. Okay, now it's practice time. So let's take a look. I'll do a couple here, you do a couple. Record the measurements. So we're measuring up to here. That's about 3.3, I would say. You guys do that one. I'll do E. Measure is 3.55. You guys do that one. I'll do this one. This one is about 62, which is the same as 15, 16, 17. Good. Compare the 3 rulers in question 1. Which ruler is the most precise? Explain. Well, the ruler with the millimeters is the most precise. The ruler with millimeters is most precise. Millimeters are the smaller than centimeters or eighths of an inch. And that would be this one. Is each quantity in an exact value or a measurement? 2 cups of flour, well, we're measuring that one. 5 nails, that's exact, you can't have half a nail. 1 meter equals, that's exact. And 20 centimeters of string, you're measuring that out. Good. Kendra and Jade measure their laptop screens. Did one of these students have a more precise measuring tool? You tell me. 300 mils versus 30.0 centimeters. Yes or no? Okay, moving on to the next page here. We got, which measuring tool is more precise and how do we know? Okay, I will do, how do I want to do this? I'll do the top part here. Okay, so a millimeter ruler or a ruler that measures to 1/32 of an inch. 1 inch equals 2.54 centimeters. Compare in millimeters. So we do 1 divided by 32 times 2.54. So we're going to convert it. That is going to equal 0.079375 centimeters. Let's convert that to millimeters by moving the decimal over. Just once, I mean, not twice. So that we get 0.79375 millimeters. So we know that 1/32 inches is less than 1 millimeter because this is less than a millimeter, it's less than 1. So the ruler is more precise at 1/32 measurements. Okay, you guys do the middle one and I'll do the last one. So thermometer that measures to the nearest degree Fahrenheit or a thermometer that measures to the nearest 1/10 of a degree Celsius. And they gave us the conversion here. So we have to convert it. 1/10 of a degree Celsius times 1.8 is our conversion to get it to Fahrenheit equals 0.18 Fahrenheit. So 1/10 degrees Celsius is less than 1. It is less than 1 because it's actually 0.18. Is less than 1 degree Fahrenheit. So the scale that measures 1/10, the scale that measures 1/10 is more precise. Okay, let's do, we got 6 here. This is probably a building one, so since it's all words, I'll just give you that one. What task requires more precision? Explain. So you gotta really think about this. Timing an Olympic speed skater or timing a roast as it cooks. What's more precise? I think an Olympic speed skater, they measure in like milliseconds. Versus a roast, it's like whatever. It's like 2 hours, 2.5 hours, something like that. Let's see what the answer is. Timing an Olympic speed skater requires more precision. Speed skating times are measured to 1/100th of a second. The time that a roast needs to cook in an oven is measured in minutes. There we go. Mr. K got it right. Okay, measuring the mass of luggage at an airport or measuring the mass of a deli meat at the grocery store. That's kind of a tough one. Like, at the airport, if you're like a little bit over, they'll charge you now. I don't know if this book knows that, but they charge you like $50 extra or something stupid. The deli meat store measures in like tiny little slices, so I would guess that the deli meat would be the one that's more precise. So let's see. Measuring the mass of deli meat requires more precision. The deli meat is measured in grams to determine the price. The mass of luggage is measured in kilograms to see if it meets airline requirements. Yeah, so I agree with that. Deli meats, it's like 276 grams will be $5 versus the luggage will be 50.2 or something. So it's just like 200 grams. It's not very precise. All right, and let's see C. Measuring the amount of coffee to pour into small, medium, or large cups at a coffee shop, or measuring the amount of milk needed in a cake recipe. I'm thinking cake because you got to measure that out with all those instruments that cooks and chefs use. Measuring the amount of milk needed in a recipe requires more precision. Oh yeah, I'm good at this. Small, medium, and large amounts are jugged and measured by the size of the cup used, not by measuring tool. Yeah, they just kind of slosh it in. Every Tim Hortons is just different for what you get for the amount of coffee and stuff. A measuring cup with a scale is needed for the cake recipes to ensure the cake is made correctly. Awesome. Okay, that is 7.1 or 2.1. The next unit is going to be 2.2. Stay tuned.